Okay, so just got back from lunch and I want to get started on the remaining items that we have for this file server. So the main one right now is making the IO more robust in situations where we have the partial reads and writes. So let's go ahead. I'm going to just do most of my editing over here. Actually, you know what? I'll do... Yeah, okay. Maybe I'll just move my display over here. There we go. Okay, let's go to the worker. The main thing I want to do here is split out reads and writes. So we have our handle event. So really this needs to be handle read event. We need to do this check outside of this function. So if we go down to handle event here, so we need to do some type of switch or conditional here. So I think we want to do a conditional because we have to you have to check membership in the set using binary operators here. That's not compatible with the switch. So this events will be events sub I events, and then this will be else if, and then else. So this will be handle read event. So I guess the question is, do we want to allow concurrent reads and writes, or even serial reads and writes? If there's a read and a write event on this thing, do we want to allow both? Why don't we? Yeah, we could just check. We can have a state machine that tracks where we're at. So epoll out, handle write event. And then here, we'll just say like, I need to pull up the man page here. Man epoll, what would this be? Events maybe? Events doesn't have the actual. Let's try CTL maybe. Yeah, here they are. Associated file system is available for read operations. Is available for write operations. I wonder if this write is going to continually trigger. I don't think so. The hup priority we don't care about. Error. Epoll hup, epoll read hup. This is hang up happen. Okay. Maybe we'll do a negation of both of these conditions. So let's grab them both. If not this and not that. Can't I take the negation out and then change it to an or? Is that De Morgan's law? I think that's how you do negation. No. I would have to put a not on the outside. And I prefer this syntax here. Okay. So you say, hey, if it was not an in and it was not an out, then hey, we had an unknown event type. And this will need to be events sub I events. All right, and then we'll just add a prototype for handle write event down here. It's pretty much gonna be the same thing here, like that. Handle write event. We're gonna try to get the lock. If we can't, we just return. If we get the lock, then we eventually unlock it. We need to think through the state transitions here. So we start in read mode. It's going to be integer. So similar to how we track the n, which is the read index, we need a way of tracking where we're at in the file for writing. And the send file syscall has an offset argument that you can use to keep track of that as a simple integer. But when I was reading the man page earlier, I saw something where it's like you can just use the file descriptor because it has a description with the seek offset in the description table. So you don't need to use the offset. It's kind of just like a secondary API. So file fd to track file offset for writing. So we do want to say which mode we're in. Mode. Trying to think like what we should do. We could use a boolean. We could say int mode. I wonder how are enums? There's an enum capability in C, right? Show me a basic enum in C that has two values, read and write. Do I need the IO operation T tag to declare a variable of this type? Yeah, I was gonna say, like, you can say enum IO operation without type def. I like that better. Let's go up here and we'll say IO mode. And in here, we'll say IO mode. Or sorry, enum IO mode. I like having the struct and the enum in the actual type name instead of doing a type def. I'm going to call this code rename. This is going to be FD record instead of request a record. Yeah, I thought that was spelled wrong. Okay, that's a little bit more robust, I think. Okay, so this FD record thing, I'm going to pull all this stuff out. All the stuff that manipulates records. All this stuff. Yep. That's a little helper function for strings. I might pull that out too. Okay, you're going to go into source record .c. Okay, lots of stuff here. This is going to need to pull in record .h, which doesn't exist yet. All right, we need pthread, obviously. Where did pthread go? Oh, here it is. Okay. Let's close this, make this smaller. Okay. The actual enum, I don't know how I lost that. And then we're going to need a HTTP. Can I just put this declaration in the header file? Maybe? I'll do it as a C file. And then I messed that up. .h. And here we're going to delete all of this and just leave it there. Variable definitions and header files can lead to... Okay, so we don't want that. That's great. I messed something up here. Move HTTP C to source. Okay. Worker. I'm gonna change this print stuff to be called helpers, because it's just a bag of helper functions. So rip grab for printers. So main, makefile, yeah, definitely. Printers, helpers, then source main, helpers, then source socket, oops, helpers, and then we have to touch source help, or no, we have to move these things. cd source, move our printers.c to helpers.c, and move printers.h to helpers.h. Okay. Alright, let's go back here. Vim makefile, we're going to need to have one for HTTP now. Okay. And then what else? There's another one. Record. So touch source record.h. Then makefile. We need to add that as well. Build record.o. Okay. Oops. Build record.o. So you got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Okay, these aren't going to build. So I need to go back to worker. And this record.c. We need to continue fixing all these pound includes that are wrong here. R limit. So that's going to be from sysresource. P error. So standard IO. In fact, I'll just do all these. Bam. Buff size. I need to include buff size, which I think is only used here. No, it's also used there. But considering it's like part of, intrinsically part of this, and we already import record, I think we can get away with that. Okay, oops. Okay, are there any other errors? Nope. Great. Here we got record try lock. We need the header file now. So I think I need to grab all of this stuff. Record.h. And well, the first thing is just to get all the functions exported here. Oops. Okay. Record C. Let's split these. Record H. Put this here. And then we're going to pound include our own record.h. That's probably good practice to do in all of these files. So I'll go ahead and do that. Let's go and quit everything. cd source epoll.c. And what this will do is like it'll force it to where we can't have a function with the same name defined in the header file that's different than how it's defined in the C file. epoll.h. It also allows us to move pound define constants, stuff like that, into the headers. Vim helpers.c and helpers.h. Okay. Now we don't need the netdb because that's being included in the header there. Great. http.c and http.h. And then here we're gonna pound include http.h. I think why is it not, it wasn't happy with me putting this here. Variable define header file. Oops, sorry. Please go back there. I need to click on here. There we go. ODR violations. I'll say I have a const char star. Should it exist in the header or the C file? Usually the head file should declare it, and exactly one C file should define it. Translation units are just private to one C file. 1C file the definition, include header H. Extern const char. Oh, maybe that's a better thing to do. Character array. And then here we can say response is a character array. Const char my string. Okay, I didn't like that because of what? There we go. Just need to have it reread the header. Okay. Okay, sounds good. Cool. Alright, so that takes care of the HTTP stuff. Then record.c should already have the include, yeah. That looks like string is not needed anymore. Great. Socket.c. Socket.h. Worker.c. Worker.h. We should probably put guards on this, if-def guards. So if we go back over to here, there's an example of an if-def guard here somewhere. Here it is, if-def this thing. Or if not def, I should say. So each one of the headers should have this imp vim epoll.h. Okay. Next one would be helpers. .h. Nope. HTTP.h. Record.h. socket.h. worker.h. Okay. Well, let's go ahead and try to make it. Okay, I got some errors in worker.c. Use undeclared identifier records. So if we go to, wait a minute, record.h, yeah, so this is where we just went down to the function definitions, but we got a share state as well. So worker.c, we need to grab the, not worker.c, record.c. We grab some other stuff here, like this, and this too. This needs to be extern. Max FDs, where is that determined? No, it's only in here. We're going to extern it anyways, why not? So it's going to need pound define pthread.h for the pthread mutex. Wait a minute. Not pound define, pound include. There we go. And then this R limit thing is, I think, in sys resource. Yeah. Okay. Good, good, good. Doesn't like this error no, but I think I need it for something. Yeah, these things here. Okay, let's go back here, make clean, make. Alright, so now we've got worker.c unlock. Unused label to unlock, that's fine. We'll just comment it out. That's this guy here. So now we're in the record.c, it needs the error no. Just record.c, yeah. Record.c 21. Yeah, but it's externed here, and we pound included it here. Record H. This is record H. Oh, we actually do need to define it as well. So if I do sorry. I think I just say this and it should zero it out. And then it needs the records as well. Records is an array, but it's an array of unknown type or unknown size until runtime. So we can't declare it as an array. Okay. Make clean, make. Alright. Build local host. Okay. No such file or directory. Okie dokie, artichoke. There should be. Oh no, that's because I typed in hello. Okay. Sorry, my mind's wandering. Okay, that's a nice little cleanup refactor thing. So now let's go back into the worker. This thing needs to move into the helpers. Okay, and if we go back to where's that terminate rip grep terminate at new lines, that's in the worker.c. Okay. Handle write event. Yeah. Okay. It's weird. Sometimes it gives me the warning. Sometimes it doesn't. It's like the first time it notices something, it'll warn me about it. Like if I do an extra new line here, say like test, just add some garbage here. And then I do make. It'll give me the warning, but then if I make again, it's like, yeah, it's fine. And if I make clean it, it's like, yeah, you're fine. It's like, gives you the warnings once per time that you touch the file, which is probably smart because a lot of times when you're building stuff, like people don't give a shit about these warnings. And so when you're building stuff, you just get a massive amount of output, warning, warning, warning. Versus getting the warning when you touch the file, I can see that being useful. So, I can make it, make clean, make clean. I'm not getting the warning, but if I touch source worker dot c, make. The touch didn't update it. Oh well. Caching must be based on content, not based on timestamps, which is actually a good idea. Like if I delete that line and then right? Why would I not want to write to the file? Yeah, okay. Let's go to the records. The reason I extracted the records is because I need to be able to reason about them independent of all the worker stuff. And the first thing is like initializing the record. It needs to be in the state where it's in read mode. So I'm just going to be a little bit more explicit than I need to be probably. But here we allocate the buffer, we initialize the mutex, we assign the buffer. Then we're going to say records fd read idx is equal to 0. I know I don't need to do this, but I'm doing it anyways. So we got the mutex, we got the buffer, we got the read IDX. The IO mode I'm going to pull up here above the read IDX. And because buffer is for reading, I'm going to pull that up as well to be the top thing here. So this will be write FFD is equal to 0 as well. Buffer, and then the mode is going to be equal to IO mode dot read. I think that's how you do it. Or enum, I don't know. It's just dot read. Okay. I'm gonna change these to be like this. Okay. So let's reset everything here. So read IDX, free the buffer, set it to null, set the IO mode here. Okay. Read init for all of them. Try lock, try unlock. Okay, great. So now we know when we start, we are going to be in read mode. Oops. Let's go ahead and close these. Just don't want to have these windows open here. Okay. Okay, so now that we know, okay, we're in read mode. I'm going to copy this here and do the same thing in the right. I'm going to say writing to. So if our read fails, we'll say if n is equal to e again, or or n is equal to e would block, then we just go to unlock. So we unlock and exit. So that handles that. And then this we can say delete that. Okay. So that's a situation where the kernel is like, hey, you can't perform this read because you're going to block. And if we man to read, E again would be the file descriptor refers to a file other than the socket, and a socket. Let's see, it would be a socket. File descriptor FD refers to a file other than a socket and has been marked non-blocking, and the read would block. So E again or E would block. The file descriptor FD refers to a socket and has been marked non-blocking, and the read would block. POSIX 2001 allows either error to be returned for this case and does not require these constants to have the same value. So portal program just check for both possibilities. So that's why we got both here. Okay. If it's 0, then we're at EOF, in which case we declare we're removing the file descriptor. We then remove it from the epoll CTL, we free the record, we close the file descriptor itself, and then we unlock. Otherwise, the read succeeded. So here I'm going to say if n is equal to buff size. It's not even n. It would be because we're reading into the buffer at an offset of the buffer. Yeah, so we need to change this to be a little bit different. So we say, hey, I'm reading from the file descriptor. The buffer, we need to advance this. Since buffer is a character star, we can then just say plus whatever our records I don't like referencing the records so many times here, so I'm going to simplify this a little bit. I'll leave a compiler error there. So this is going to be a common thing. So once I acquire the lock, I'm going to say record is equal to a FD record pointer. And this is a struct. And that's going to be equal to that. And I need to take a reference here, I believe. There we go. So now over here, everywhere I say records now, I'm going to replace with that pointer dereference. Because when you go through an array, you're basically going through a pointer anyways. I mean, it's different. Last time I looked at it, I think the array indexing is a little bit less crappy. I think the array index, even though the array itself is a pointer, I think the compiler is a little bit smarter about arrays and computes the offsets a little bit more efficiently and like doesn't require like an actual dereferencing. I think. I don't know. It's been a while. So I looked at this assembly, but I'm just getting tired of typing all that. Record. And then this needs to be an arrow. I just don't want to have to pay the cost of dereferencing every time. And I don't know if the array allows me to avoid that or not. But we'll see. Record. Read IDX. Okay. So here we're going to perform our read, and then we need to compute the offset based on record read IDX. And this is going to be buff size minus record read IDX. And since the buff is a char star, I don't know how to do the point arithmetic on this. Like that. Hey, that's all I needed. Just need to be able to spell my stuff correctly. Alright, so that'll perform the read. It'll read from the place that we left off in the buffer up to the max buff size. So say the buff size is 10, which we should probably test this test case. But say it's like 10, and we read all the way up to 10 initially. We come in and we read. The read IDX is now at 10. Actually, let's just make it simple. We'll do 2. So we have 2 boxes to read into. So that's 1 box. Oops. That's 2 box. This is box 0, obviously. I don't know what's going on in my editor here. And that's box 1. So we start off reading our IDX is at 0. Thanks. We perform a read, our n is 2. So we advance that to 2. So now we're off the end of the array here. But then we say perform a read buff size minus record read IDX. So that'd be 2 minus 2 is 0. So here we can just do a quick check to say if this calculation would result in a value that is less than 1, then we've already hit the limit here. And we just need to respond with this 403. Go to unlock. And then this is where I want to use the HTTP stuff. HTTP H? No. Yeah. Let's do another one of these. And we'll say response is what? 431. Let's look at the Go source code. Sorry, it's the wrong. Let's send that to 4. Send that to 4. Okay. Let's look at Go source code. Golang net HTTP status codes. They have a really good implementation of HTTP. So 431, let's see what that is. 431 is request header fields too long. That's the header fields too large. And that's the message there. Okay. So I'm going to say, hey, 431, and then this is the message here. Oops. And then 500. Oops, that's 400. 500. Status internal server error. And it's internal server error. Internal server error. Okay. So here I'm going to look for 500. I'm going to do a little helper function here and say void write status. and then you give it the status. And it writes it out to the FD. That means stir_len, which is string.h here, needs to be part of this, which would be above here, I believe. That's the right way to do it. And then we need write would be fcntl, I think, which we need to keep in here because we're doing reads, which I think are also in fcntl. Alright, so we have fcntl here. Wait a minute. Maybe it's Unix standard. .h, there we go. Okay, so we do our write. We don't care if it succeeds or not because we're just trying to get it out there as best as we can before we so this is p error on open before we go to unlock. I guess that's fine. Okay, here I'm gonna say write status. I'm gonna say this thing is a status 500. Go to unlock, and then up here, here, status 431. And I realize those are the wrong names. I need to rename this stuff. Oops. Code rename. Call it status. Code rename. Status. And then we'll do another split here for http.h. And then this is going to be status 500. And then status 431. There we go. And then we also need to give it this guy. There we go. I like that. Okie dokie, and then here, okay, now this thing's freaking out because I took away something. fcntl, did I take that away? I guess I did. Thought I put it back. Status 431. Oh no, we need the FD here. Write status into e.data.fd. And then down here, same thing. e.data.fd. Wait a minute, did I mess this up? Right, sorry. Write status. Okay, there we go. So we have to pass in the char star status, and then this should just be status here. And then http.h char star status. There we go. All right, that's better. Not a huge help, but it just helps clean things up so it reads better. Passing a const char parameter discards qualifiers. Okay, maybe we go back to our http.h and http.c, and in here instead of a char star we'll say const char star. Maybe that's what I need to do, because I know I can't pass the array itself as an argument. Okay, that seems to make it happy. Sterlen. Oh, we're doing another 500 here? Okay. This is if the fstat fails. This is if the send file fails. Okay. All right, we are not at the point yet where we're splitting out the writes from the reads, but we did solve this problem where we had a situation where we read the header up to a certain length and we exceeded that length. The buffer size of the headers was too large, in which case we write the status out. I think we should close under that situation as well. Yeah, I mean, find it hard to recover from that because the client's going to still be writing, but now it's writing from the place where it left off, in which case the header is going to be broken for the next request and probably the next one. So I think if you get to this state, you just need to close the connection. So I think we need a routine to do all that stuff, which we're seeing here, which is basically closing the connection. So I'll create it as a separate function up here. Void close connection, EFD, and that'll be a integer EFD and integer FD. They call it EPFD, not EFD. And then this will be FD. So we're removing the FD, call delete. If there's an error deleting it from there, then we blow up. And then we free the record, and then we close. So I think that's what we need to do here. So this will be close connection from the, does this record free monkey with the mutex at all? I don't think it does it? No. Record free does not monkey with the mutex, so we're good there. Close connection of EPFD and e.data.fd. And then we also want to do that if we're at EOF here. So any like really bad error situation, that's not like a exit the process error situation, we want to like handle that. Okay. Okay. Let's go ahead and make sure that our program's still running, building and running. So we'll make, okay, so we got this unused parameter EPFD and handle write event. That's not good. Oh, that's just the thing we haven't implemented yet. That's fine. Okay, build main localhost. There we go. nc bam. readme.md bam. .git ignore nc source main.go, not main.c. And then here teardown dot get ignore. Wait a minute. Something's wrong there. I said dot get ignore and it gave me back main.c. The hell? How did that even work? How is that working? Can I attach the debugger and see what's going on here? psaux and grep for main. It's gonna be a lot of stuff. Here it is, localhost. This guy here. Let's clear that. GDB. Sorry, man GDB -p. I think it is. Yeah. GDB-p. This thing. Quit. Sudo. There we go. Continue. Because we're an epoll wait and we got the interrupted system call and we didn't handle that. So let's go ahead and handle that. So there's two bugs here. For some reason I was able to like just say get ignore and it's like, oh, here's the main.c. And it's like, wait a minute, that's not the file that I requested. Let me block this spammer real quick. Please go away, spammer. Alright. So there's a bug here, so I'm gonna add that to do. Fix.get ignore bug. Okay. Before I do that, which is an important thing for me to do, I need to fix this interrupted system call thing. So the epoll waits, which would be in, I think they're going to be in worker, most of them. Epoll wait. Yeah, here. So if it's interrupted, then we just want to continue. So I'm going to bring back my man page here. I don't think I need these right now. Actually, let's just close them out. Epoll wait and enter. So we'll say if n is equal to e enter. Oops. Then we just continue. Oh, we hit a epoll wait where we exited. Is that because we accepted the signal and we had interrupted system call, which is fine, but then we died. That's probably because we got a signal that we couldn't handle, maybe. We'll say not equal to eenter. Then we'll do that. Otherwise, just continue. So that's the worker, but there's also the epoll wait down here, which exits. That's the problem there. So in here, we actually do want to do the same thing, I think, as we were doing here. It's just continuing. I don't think we want to exit. Like, why would we want to exit? I think we just continue. We log it out if it's not eenter and we don't expect it, like this invalid and stuff like that. We just log it out, but we continue to go back into the epoll wait. I think that's the right thing. Make what is this worker T? Did I mess something up there? Let's see, foreground 89 on worker.c. Did I mess something up? Maybe. Okay. Make. All right. Let's go ahead and run our thing again. Oops. Build. Okay. We'll get out of here, and I can just get my PID from here. I don't need to do a PS. And then if I do the same thing here, if I give it that, hit continue, it gets interrupted because of being p-traced, but at least it's continuing. And now I can put like a breakpoint on where I'm interested in, which is like the freaking, what was that file? I forget the name of the file or the function. Let's go epoll Fileserver. Worker. So in this situation, we saw this bug where we requested a file and it gave us a different file. So what I want to do is set ptrace, set the debugger to break on string terminate at new line. That'd be a good one. So before I even open it, Oh, okay, so we're advancing the read IDX here. That's the problem. Once the read completes, we need to reset that read IDX. That makes sense. So this read completes successfully. We don't get E again. Errors. We don't get EOF, in which case we're closed. We just get a regular read, in which case we increment the read IDX. And then we're going to try to find that new line termination. And what we're going to say is, like, if the new string terminate at a new line, so we need to say here, if, you know what we need to do? Do write separately? Here, we'll say switch to write mode. I mean, we can try doing the write in the same, let's see. I guess we could try doing it. And we only need to switch to write mode if we have a partial. Yeah. Okay. So we have a read complete, but we don't know if we're done with reading the full header, right? This is where I think this needs to change. Yeah. So instead of string terminate at new line, we're going to say if not done reading header, and we're going to give it the record buff and the IDX, record read IDX. So you say if we're not done reading the header, then we're going to continue reading, in which case we just go to unlock. If we are done reading the record, then we attempt to do all this stuff, and at the end we need to reset some stuff here. So actually no, we can probably do the resetting over here. So this IDX needs to go to 0. I'm going to call this thing buff to path. Header buff to path. Because what we're doing is we're taking in the buffer, which is a pointer, and we're taking in the IDX, which is an index, into that buffer, and we're going to read up to that IDX. When we find the path, we're basically going to terminate that buffer by putting a null character, and then in the case of HTTP, we're going to have to move some bytes around. And that might just be increasing the pointer, but I don't really like that because I guess that's fine. So it's going to return a char star, which is the path. Header buff to path. This then gets set back to 0. We then use path here. And then we use the FFD from that on there on out. I think buffer is no longer used here. Of course, he named it stat buff, but I think buffer itself is no longer used. Look at that, the window resizing. That happens even without GDB, I think, but just ignored. Okay. All right. I'm going to get out of GDB. It's nice that we have this. Yes. This guy should be done with that. I should just be able to netcat to it. Yep. Okay. Okie dokie. So we got some things we gotta build here. Like this done reading header, which I think probably should belong in the HTTP section, right? Seems about right. HTTP.h. Let's add it there first. We'll say, hey, bool. Done reading header takes in a char star buff and a integer IDX. Would you say I? Okay, and then we'll do http.c, go down here, we'll implement this thing. And this is going to be similar to our helpers. So I'm going to pull that up here. Oh, did I do the wrong one? Yeah, I should have done split. Yeah. Helpers C. String terminate at new line, this thing. So it takes into size T. That's a good type. Size T. I like that better. We'll say, yeah, max len. I like that better. And then the implementation here is going to be slightly different because we're returning a bool. We're not mutating things. So you go from 0 up to the max length, and if we see a new line, then we return true. And then, or if we see a null byte, I think that's an error case. Let's just return false here. And then we need to include standard bool. And then I need to update my header. Okay, so we can quit out of that, split up the source http.h, change this to be a size t. And then size t, where does that come from? Got me. Probably Unix standard.h. Where does this thing come from? Standard def? Probably Unix standard.h, I'm guessing. Yeah, okay. Alright, so that takes care of the done reading header, which I'll add a to-do here. To-do this once we implement. Okay. So we're done reading header once we hit a new line here. And then header buff to path. That's the next one. So it's going to be char star. It's going to accept pretty much the same arguments. But this one's going to be a little bit more. It's going to mutate stuff, basically. So this one can be a const, because we're not going to mutate it. Const char star. I think that means that we don't mutate it. I don't know. I need to finish reading the C manual. Okay. Yeah, because I mean, we do the right status here. It's const char star. Header buff to path. Let's go ahead and copy the prototype. Put it up here. Add an implementation block. Copy a for loop. Even though we don't need the bool thing, I copied it anyways. So in here, what we're going to do is we're going to say PTR is going to be our char star. And it's going to equal to buff here. And we're going to return PTR. And we're going to modify this as well. Size TI. I don't like that. Why did it give us size TI? Let's call this max length. Max len. Max len. Boop, boop, boo. Max len. Otherwise, conflicts with the indice of the iteration. Okay. So in here, we're going to read up to when we hit the new line. And then we're going to say, hey, this is where we do our modification. So this would be our helpers.c. Basically this. We're going to do this for now. Return PTR. We can return null here. I think we should print fprintf unable to. I think we need to return null here, and then we need to handle this null here. Header buff to path. If path is equal to null, then we need to close up shop. So we're going to say close connection and unlock. That's kind of like our big abort. And then so this guy's going to go through and say, hey, if we hit a new line, we're going to replace the new line with the null byte, and we're going to return the pointer. And this will allow us to advance the pointer when we switch over to HTTP. So we're not tied to the pointer being the same thing as the argument here. We can modify the pointer. Future planning. I'm planning ahead here because we're going to need it. All right, so now we got our path. Looks good. All right, so this should all now work. This should fix the bug that we saw earlier. Come on, write everything. Let's go ahead and I'm just going to maybe minimize this. Quit out of this. We'll do a netcat here. Can't connect yet because I haven't made it. Make and run. And netcat, and we'll say ASDF, and we'll say .get ignore source main.c .get ignore. Okay, it's behaving correctly. You don't need to for that. It was pretty easy to reproduce. All right, so this guy is done, but we're not. Get status. Oops. Get status. Get add-on. Get status. Okay, great. All right, so let's get a little bit more screen real estate here for our editor. All right. Worker.c. I do want to try to do a write to a socket that's flushed without the new line. Let's see if AI can generate me a test program here. Say, hey, can you write me a bash script that uses netcat nc to connect to a server, perform a write of, say, the partial string source, then flushes that write to the socket, waits a little while, then performs a write of the bytes Hold on, I gotta be right back. Hey, sorry about that. This neighborhood kid just likes to ring my doorbell and run away. All right. Where was I? Oh, we want to see if I can write this test program here. So yeah, it does a printf, a sleep one, second write, empty string. Okay, let's try that. I mean, it's kind of what I was thinking. I just didn't want to write it. So let's kill this. Make everything. Let's write all. Write all. Make. Run it. And then we'll write this little test program. Vim source partial write.sh. We'll say $1 and $2. Say echo to standard error, which is, I think, like this. We say we'll say 2 here, and then we'll do something similar where we're writing main.c with the new line. And I think I might need to single quote this to get that to come through. And then that'll be it. Okay. And we'll go up here, hashbang, bin bash, chmod plus x, that guy, and then we run that guy with localhost 12345. Actually, I'm gonna say mv this. Oops, damn it. How do I perform a read? I think netcat should perform the read for me, right? Source partial write. Maybe we'll do a sleep here. Let's output the current state when we get to this. Let's go over here. So we say reading from that, type that. We'll say state is equal to record. We'll call this the read IDX. Read IDX. Record read IDX. Okay. Oops. Go away. Okay. Where is that? Worker. .c. Alright. Let's bring these guys back. Let's open up source partial write. And then we'll try doing 2 of these in a row. Why not? See what happens. Make data argument. Okay, so I forgot to do my formatting here. Read idx %t d. Here we go. There we go. Make. Okay, let's run this. And then we do this, read idx 0, 4, 0, 4. So you see it didn't hit the new line because my guess is that this thing is not actually echoing out a new line. And we could test that just by creating a little terminal here. Kill that. So if I vim source partial right. So if I do print f and I say, hey, main.c new with a new line. Oh, it's gonna do it. Okay. Read idx and we'll say the buffer, which, what do we call the buffer? Record, it's just called buff. Buff. Even though it's the header buff. Alright, we'll just call it buffer for now. And we'll do a %s here. Quit. Record. Buff. But what I want to do is I want to print in C, how do you print an array out as if it were a string, an array out for debugging, as if it were a string, but up to a specific place in the buffer as an offset. Okay, what the frick is this? Print a string with precision specified at runtime. Okay, this is new to me. Dot star. And if I do that, will it freak out because I didn't give it the precision? Let's see. Yes, it will. It's saying that precision type should have type int. So now I got to give it the IDX again. Okay, you like that. Okay, let's go ahead and run it then. And we'll run our little test program here. Resource temporarily unavailable. What the hell? It should have handled that. What is resource temporarily unavailable? I think that's E again, right? Yeah. So it says read here got a resource temporarily unavailable. We handle that here. Where if the read gets that. Read. Oh, there is an epoll add. No, that's not. So had it been here, we would have gone to unlock if that was the case. So I think this is a symptom of the read not setting error no. Man to read. On success, number of bytes returned is returned. 0 indicates end of file. File position is advanced by this number. It is not an error if this number is smaller than the number of bytes requested. On error, -1 is returned, and error no is set to, yeah. How is that even possible? Well, let's try it again. I don't understand how this is even possible. Clearly it is. And we have a little test script to reproduce it, right? Once we completed our read, I want to do another log here. Read from FD. Oh, this needs to be plus equals n. Well, that's a bug right there. All right, make. There we go. Okay. Okay. Looks like it's working. Okay. So we have our partial reads done. Basically, you have to read. So now we can delete this to do. So if our read blocks for whatever reason, we just unlock and continue. If our reads error out for any other reason, we blow up, which is what happens here, but I don't even know how it's possible because we handle that condition. Something funky was going on there. I need to see that again for me to dive in deeper. I'm not going to look at it now though. In here, our EOF, we just close the connection, close up shop, unlock, continue. And then here we increment our n, or read IDX by n, so that we're writing to the right location. So you can see that here. Our buffer started as empty. We got 4 bytes. Then we start at the 4 bytes, and we got up to 11 bytes. Yeah, the other one was going to 7 here. What's funny is it wrote it to the right location, but it just truncated it wrong. The read IDX went to the wrong location. Oh, because no. Oh, because you're setting it to equal n. So the first go around, we set it to 4, which allowed us to write it out. But because we didn't increment it, when we go to read it out, anything that uses this read IDX after this, like the done reading header thing, wouldn't be able to read the full thing because it would just get up to the 7 instead of the full 11. So this is the bug right here. All right, so all of that is done. Cool. All right. Basically, once we hit read IDX is 0, if we ever hit a situation where this we need to like close as well. No, we don't need to close that. We can write status. Here we do need to close though. We need to close the FFD. Close of FFD. Because we tried fstatting FFD, it gave us an error. We need to write out, hey, there is a error, and then close it. All right, so now we're in this part of the code where we're sending file. If this thing partially completes, we need to switch over to write mode, put the state of this operation onto the record, the file descriptor record, and then also move this into write triggered for further IO operations. And then we need to implement this handle write event. Which I guess we could say let's handle the whole write event. Yeah, let's just handle the whole write event. Simplifies it a little bit, the implementation here. Okay. So we have writing to type. I'm going to comment this out because this is really only useful for debugging. To do add debug logging mode disable for now. That's fine. And then here we're going to, do we need to fstat it? I think we only wanted to fstat it so that we could do the send file offset, right? Here, the stat buff st size. Let's do man, oh, you can kill this as well. Man to send file again. So size t count. Yeah, I think we do need that. And then the offset we don't need. Offset. If offset is null, then data will be read from the file descriptor starting at the file offset, and the file offset will be updated by the call. That's what we want. Okay. To do kick over to write mode. And then once we're done here, we have to say to do kick over to read mode. So it'd be really nice if there was a way that we could just mutate the state and place this thing into read or write mode very easily. So I think that's going to be in our record.c. So we're going to have like a function here, which is going to be record set read mode fd. And then in here, if we look at our structure, see if I can fit another buffer here. Read, record.h. So this is our structure. So this is going to be setting the mode here. We need to do a mode check as well up here. Handle read event. Once we acquire the lock, we need to do a mode check. And then we'll do the same thing down here. Once we acquire the lock, do a mode check. Record set read mode. Oh, it's getting pretty late already. 5:22. Time flies when you're having fun. I think tomorrow I'm gonna just take off because I got some personal stuff to take care of. But I'd like to get this at least in a state where the reads and writes are being handled, and partial reads and partial writes are being handled correctly. Okay, so record set read mode is basically going to look up the record. So it's going to be events sub fd, not events, records. I think it's called records, right? Yeah, records sub fd dot mode is equal to IO mode write. And then at this point, our read IDX needs to go to 0. Which if you look here, we're already doing that here. So we can take that out and just do it here. This will be transitioned to write mode, sorry. So we have the mutex acquired, we set our mode, our char star, we don't care about the state of it. Maybe we write a null byte in the buffer. That might be a good way of like resetting things. So we say buff sub 0 here. We're going to write a null byte. So that just says, okay, throwing away all the read state. We don't need any of that anymore. But the write file descriptor needs to exist. Int ffd. So we have to say here, write ffd is equal to ffd. Yeah, so that's everything. So then we'll have a record transition to read mode. So this is obviously going to be read. Our write FFD needs to be closed. which I think we can handle in the writing itself. Like we know when we're doing the transition. I guess since it's part of the transition, should probably just close it in the transition, right? So we can say close, come on, of the right FFD. And we also want to set that to 0. You gonna freak out on me? What's going on here? Okay. Why does that want to freak out? There it goes. So we set our mode to read. We don't really need to monkey with this. So we're transitioning the state to a write mode. We just need the write FD. When we transition to the read mode, it's like resetting everything. So it's kind of like the initialization here, but we're not doing the allocation. So we set read. The read IDX can be set to 0 as well. That's fine. The buffer can be set as well, which I guess it should be done in this order because that's the mode buff read IDX write FFD. Okay. So we have these transition functions. We do need to have our headers updated here. So let's go ahead and do that here. I love header files. They're my favorite. Sarcastic. It's like, why do you have to have a header file that just repeats the prototypes? It's so annoying. We don't need this FFD here. Okay, so we got our transition stuff done. Okay. So now we can do our transitions here. So in the read event, we need to do a mode check. We'll get back to that. Actually, we'll just do our mode check here. We say if, so we have our record here. And we'll just say if record, and I need to do this in parentheses because C is fun like that. Mode is not equal to IO mode read. Then we just say go to unlock. It's like you need to be doing your writes, bro. I'm not going to handle you here. So this should be after, so we acquired a lock, we put a reference thing here, and then we do our check. We need to do the same thing here. And then this needs to be a check for write. Go to unlock. And now that we have that, I can uncomment this. Yay! Okay. Boom, 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 boom. All right. So this will be our. Oh, the other part that we have to do for the transition is also set all the frickin' stuff with epoll. Record transition to write mode. And we give it our FD, which is the E data FD. Yeah, E data FD. Do we even use this epoll? We use it to close the connection, and we also use it, we'll need it to transition it as well. So this will be e.data.fd, and then this will be ffd. And this closed connection stuff, where is that? That's up here. So we're going to do the same thing. We're going to have a we have a function here, and we're going to say epoll so there's this delete here. All the epoll CTL stuff I feel like I need to pull out into helpers, which is just this, which is great. So epoll C. So we need to add the right. So epoll add right. This will be epoll out. FD. Do I want to do one shot for these things? I don't think so. We're only ever going to add read, and then we're going to update it to write, and then we're going to delete it entirely. So epoll CTL add, we actually want mod. Epoll mod right. Mod right. Okay. CTL mod. Okay, there we go. And then we want another epoll mod read. Epoll mod read. Okay. Okay. Epoll mod read. I think I can do these as, I don't think I need a little function in there. I think I can do that just from here. And then finally I want a del. This needs to be in though. I need to make sure I do that. Epoll mod read in mod blow up. Great. So this is going to be epoll del period. Del. So we don't need this because it's null. So we say epoll CTL. This is going to be CTL del. FD null. No, please. And then we do the same exit failure here. Okay, here we go. We say epoll del epoll file descriptor and file descriptor. And semicolon. Okay, so now I need to add all these functions to, oops, yeah, to my header. I'm just going to epoll.h. Okay. Let's go ahead and write this. Okay. Okay, down here we can now say epoll. What did I call these things? Mod, right, and I pass in the epfd. And e.data.fd. Okay. So basically, we do our read, we get everything statted up on the file, assuming all that works. Then we take that file descriptor, transition the record into the write mode, and then modify the epoll to say, hey, only trigger on writes from here on out, ideally. And then we just unlock. So now we're in the write event function. So this is going to be the inverse of this to kick it back over to read. So it's going to be a record transition to read mode, and that's not going to require the second argument. And this is going to be epoll mod read. So we can bounce back to the read state. Okay. I'm actually going to split this with itself and scroll up to the read code here. And I'm just going to highlight it. It looks kind of weird. But pretty much everything down to here, and then some done check. Yeah. So we have our IDX that we statted. We did the stat. We're not using it. Isn't that funny? It's needed by send file. Even though send file has the offset in the file descriptor, unless we want to restat the file descriptor each time, which I guess we could. I don't see why we can't. Yeah. Let's go ahead and restat it every time. Or we could store the stat in the state, but I'd rather just restat it every time. So here we just do the open. If the open succeeds, then we transition into the write mode. That makes sense. Okay. Now that we're in write mode, we stat the file using fstat first. If anything goes wrong with that, we just write the status out as a 500, close the file descriptor, go to transition to read. Otherwise, we are able to stat it, and we've done our reading. We're ready to write. So now we do our send file into the file descriptor for the socket, our file descriptor, which we get from, where do we get it from? I think that's, yeah, it's unknown. So this needs to be pulled in from record write FFD. So everywhere there's FFD here, I need to fix that to be record write FFD. Okay. So if n was -1, then there's an error. If it's an e again, so we got to handle the e again, sorry. The send file here, if we look at read, we just say less than 0. So we'll do the same thing here. Less than 0. Then there is some error. This read just blows up. Maybe that's not the best thing to do. Can't we just like close the connection? I kind of like closing the connection. It's like, okay, well, the read blocked for whatever, or read blew up for whatever reason. Let's just close the connection and go to unlock. And we can write a status out if we can. I'd rather do that than exiting. This will be a 500. Close connection, go to unlock. If n is equal to 0, there is no error. We just close connection, go to unlock. Okay, great. So if n is less than 0, we need to check for this case first. If it's E again, then we're just going to unlock. We're not going to transition. We're just going to unlock. If there's something else, then we're going to write the status out. Instead of going to unlock, we're going to close connection and unlock. Close connection. Record transition to read mode. Okay. If I go back over to here to record C, transition to read mode is going to close the write file descriptor, which I think is fine. It doesn't have anything with closing the socket file descriptor. Okay. All right, so that's if less than 0. If reading is 0, that means we hit EOF and we're done. So that's great. This means that there's no further reading to be done. There's no further work to be done. But in this case, we want to just transition to that. If n is greater than, this is where we need to check to see if we need to increment our record so we have the amount of bytes that we wrote. We have the amount. What we need to do is say, hey, is the size and we need to stat it again, basically. You say, hey, stat records write file descriptor. Write your stuff into stat buff. If you error out in the stat, we're going to close the file descriptor, close the socket. Okay, this transition to read, close, FD write. That's kind of wrong there. Because transition to read will close that file descriptor. It's going to re-look it up and it's going to close it. So we don't need to close it on our own. We want to only close the socket. This code is responsible for closing the socket, not the read file descriptor. Because transition to read will handle that. And then this needs to be transition to read mode, not record transition. Okay. Okay. We'll say to read mode. Transition to read. Okay, that's better. Let's go ahead and see what this clang error is. Use of undeclared identifier n. So we just say int n. Although I think this is a size t. Yeah, s size t. I think read is the same here. Yeah. On transition to read. Okay, and this thing's redefinition of error. We don't need that. Okay. So the second stat, if the second stat fails, we write out of 500. I mean, we've already been writing stuff out using send file. Oh, we need to write a header too. I guess if we write the header in writing the header would probably be easiest done in the read. I know it sounds weird, but we'll just add to do here. Write HTTP header for file contents. All right. So here we say if the stat buff there's size. Is it stat? Maybe it's not stat. I thought this had the seek offset. Okay, it doesn't. It has size. That's another thing. And blocks and stuff like that. inode numbers, modification times. Does not have the seek. So give me the C code to read the seek offset, the current offset of a file descriptor or a regular file. So this second stat is not needed. To do check if we are done with write or need to write more. Okay, here we go. We do an lseek of 0 and we say, hey, seek current. Let's read the man page for lseek. Man to lseek. Seek current file offset is set to the current location plus offset bytes. The offset is 0. And the return value will be the resulting offset location as measured in bytes in the beginning of file. On error, the value of -1 is returned. And error node is set. So we want to do an offset read here. I'm going to close that out. So we got a send file. And that's giving us back some number of bytes. We say, hey, what's your current offset? If it's -1, that means that we got an error here. We're just gonna, I don't like doing this right after a send file, because I say just close connection and go to read. P error, close connection, go to read. This thing I think we can get away with writing the status, because the send file might have just errored out and not written any bytes. Okay. So this is going to be e.data.fd. No. Too many file descriptors. There's going to be record write FFD. Okay, so now we have our offset and we have our size, and we're going to say if offset is less than stat buff dot st size, then we need to continue. So then we're going to go to our unlock. Otherwise, then we transition to read. All right, I think that's a pretty decent implementation of the partial reads and writes. Let's see if it works. So let's do make here. I'm gonna minimize this window here a little bit. Okay. So we got make, that's running good. Build, bam. Okay. Let's run our partial here. I wonder if there's a way to do like a partial read. Let's do cat source partial into, or just cat it out. It's fine. I have this program to simulate partial writes to a file server. I want to also simulate partial reads from clients of the file server. Can you give me a shell script that does that? Use DD, interesting. And this file descriptor connection, interesting. That's pretty cool. Partial read. Oops. Copy, copy, copy. Boop. $1. I don't like extra names here if they're not really like used more than one location. That's self-explanatory. Default true, read only 4 bytes at a time. We can bump that up to like what, 20 bytes at a time. 20 from file descriptor 3. And then this Z chunk, if it's 0 basically, then otherwise you print out the chunk directly. And then we say, hey, I read 20 bytes, baby. But the length could be different. The chunk could be smaller. And then we sleep too. And then here, I guess this closes the file descriptor. Yeah, we're not going to do that since we're in a shell process anyways, like a subshell. All right, so we got our thing going here. Let's go ahead and change mod plus X, source partial read. We need to also do our write. So connected, writing, request, then reading slowly. So our write, I'm going to read in source, or not source, bin, partial. Wait a minute. I put those under source. I meant to move mv source partial read to bin, mv source partial write to bin. Sorry. And then vim. Let's go to partial read, and then we're going to read in partial or bin partial write, and then here we're just going to do a full write. So we're not going to do the sleep. We're not going to do these echoes. We're just going to do a full write into the file descriptor. So we say, hey, that's going to &3. And we just do it like that. I think that's how you would do it. So you establish our connection, we do our write, source main C, and then we read 20 bytes at a time. Okay. Source partial, wait a minute, source. Bin partial read. Okay, blew up. No address associated with the host name because I didn't give it. Localhost 12345. Okay. Oh, connection reset. That's a cool error condition I need to catch. Connection reset by peer. So it was doing the send file. Huh. Let's try that again. Make, and then nc source main.c. Source main.c, or we'll do like a different one, main.h. Okay, source main.h. That should be a 449. That should be a 44. Not an internal server error. Let's fix that real quick. Why not? All right, so we are doing our read. We get to the point where we have our header. We perform our open. So here we're going to say if it doesn't exist, write status, and then go to unlock. This would be status 404. Oops. And then I need to man up the man to open, and then look at the status return codes here. Other errors. So this would be E. I thought it was exist, no exist or something. Exist. E no ent. E no ent. O create is not set, and the name of the file does not exist. Yeah. That's what we want. So we say if ffd is equal to no. If error no. because FFD is guaranteed to be -1 here. If we look at the returns, let's get past here. Yeah. Okay. Let's write that, make up our stuff. We need a 404 status, that's right. So http.h, we need a status. Let's order these correctly. 404. And then we'll go to http.c. 404. And we'll say 404 not found. All right, let's go ahead and make, rerun. Here we're going to say netcat, and we're just going to give it a bunch of garbage. Here we got a 404, cool. So then we say source main.c. Wait a minute, that's not good. What's going on here? Let's go back to worker, and the problem is we wrote our status, but we also have to, like, we can't just unlock. We need to reset. We could close connection. But we basically need to reset our state. That deserves a closed connection. That is fine to just unlock. If your read failed for a reason other than these non-blocking reasons, then that deserves a close. Of course, if it's at EOF, then it deserves a close. But down here, if we're not done reading, then we just continue. We go and unlock. Down here, though, header buff to path. If we're not able to convert the header to a path, then we should close connection. Should probably write to do. Should probably write out 500. And then here, this is a situation where we tried to open it. We got all of the user stuff was fine. Then we So all the user stuff was fine. And now we're just trying to open the file. And if it doesn't exist, then we do a 400 or 404. We should not have to close the connection after a 404. The problem is though that we unlock. If we don't close the connection, then yeah, we're going to be in a situation where we need to reset our state, which is fine. We just need to add that, but it's a little bit of logic that I don't want to add tonight, so I just added a to do here. Same thing for write status on other issues with open. Don't want to have to deal with that. Okay. So now if I make and I do my build and I go over here and I say like ACF, it's just going to close the connection. And then if I go back over here and I say main.source, main.c, it's going to give it back to me. And then it's going to not found my new line. Source, main.c, readme.md. What's another one? I guess I go in .get config, right? Nothing's stopping me, right? Well, that's probably not great, but it is what it is. I'll add a to do up here. Say to do should probably ignore dot files. Okay. All right, everything's working. What was my issue? Oh, I was testing the partial reads. That's right. Okay, let's get out of here. And let's run our program to test the partial reads. So this is going reading, writing, reading, writing, reading, writing. So this is next one's gonna be a read, and it should be a write. This write should not block. It should do a write and then go back into the epoll, do another write. So let's try that out, which would be bin partial read. We should get multiple writes here, and we're not getting that. But what I can do is, since I don't know what state it's in, hitting Control C here should not read connection reset by peer. Okay, so we're in the middle of a read. Again, should be on the right side, but we got kicked back over to the read side because I guess the send file wrote everything into a buffer and pieced out. So basically, it's hard. We need a large file is what we need to get the send file to behave. Let's do that. So dd will do like input file is equal to dev view random, or yeah, why not? Dev view random. Output file is equal to temp big file. BS is equal to 1000, and count is equal to 1000. Is that how you do it? Man dd. Count is the block. BS is the block size. So that's going to be basically a meg. That should, I think, create a file big enough. And then I'm just going to like base64 encode this thing. Base64 encode. I think it's encode, right? Or B64 encode. I don't have that. How to base64 encode a file on Arch Linux. I think it's B64 encode. I just called base64. What? Okay, that's a new thing. And then we're gonna say temp big file to temp big file.b64. Why did that not work? Oh, I need to redirect it, sorry. Damn. Okay, that's to be expected. Temp big file.b64, a bunch of garbage, cool. Alrighty, so now when we do a read, we should see multiple writes. And then I also want to do my, I need to fix this connection reset by peer. So let's go back to our read here. So this thing's getting connection reset by peer, in which case we want a connection close. But we don't want to exit. So how would that, so we write status. I imagine this write fails. If the read failed, the write's gonna fail. And then we go to close the connection. And for some reason it blew up. I need to debug this. To do debug situation where client closes connection and server crashes. Okay. Alrighty. Okay. Lots of to-dos. So I'm not going to debug that right now. I'm going to create a new split here. I'm going to go to source github.com cipher0dev epoll Fileserver, and then in here I'm going to run the bin trace iobt, and I have to give it the PID, so I'll rerun this, make, and we'll rerun this, and we'll give it the PID. That's not the PID. That's the PID. Oh, I need to sudo it. Okay, so we got our probes going. Our workers are waiting. So now we're going to do our partial read. And this one, I'm going to do a specific file, which is going to be bin partial read. Sorry. Temp large file dot b64. I think that was the name of it. Temp large file dot b64. Temp big file dot b64. Okay. Big file. Okay. Okay. So that's good. So now we're going to do a partial read. I should probably pass that in as another argument, but it's fine. I guess it's still not big enough. I guess, and I also want to emit the probes as they fire for enter on here. So let's kill that. We'll kill this. And that'll kill itself because of that stupid bug. Okay, let's go ahead and open up our bin trace IOBT. And then when we do our enters, I also want to printf out here. Printf %s %d, and we'll do a little like thread ID here. This will be our TID and our probe. I think that's what we want, right? Yeah. Okay, so let's make, not that there's any changes, rerun it, give us some new lines here, rerun this, and we're going to need a different PID. It's this PID. There we go. And then over here, we're going to run our partial read. Oh, fuck. I forgot new lines on all this. Okay, Vim, this thing. I always forget my new lines in my printf. Okay, new line, which is especially insidious with line buffering. All right, there we go. There we go. It looks like these guys are bouncing back and forth a bunch. We only did one send file 64. Maybe we need an even bigger file for this send file thing to get like blocked. I'm trying to get send file to block because the kernel is happily accepting the file descriptors and how much data to write. And it's like, I got this, no problem. But what if it's like a lot, a lot. So DD. So that's 1K. So that's 1 meg. So what if we do like, that's 100K times 1,000. Why don't we just do a gig? So that's 1 megabyte times 1,000 would be a gigabyte roughly. And then we're going to do our base 64 encode of that file. So now we have this huge 1.4 gig file. We're going to run our main. We're going to run our program here. And then we're going to run our partial read. And then this is gonna, if I control C, this is gonna be a read connection reset. I know it's a send file connection reset. Nice. So I'm gonna read less slowly, so I can see that write happen multiple times. I mean, you can see it here already. Writing type 28, interesting. So reading's always type 1. All right, bin partial read. It's a little bit too slow for my taste, so we're gonna read I don't want to printf out the chunk. I'm just gonna say how many bytes. So we're gonna say chunk size. Chunk size is equal to what? 100. So that's like what 1 meg. Dollar chunk size. And then if chunk is 0, then we say collection curls break. Else we say dollar chunk size bytes. Sleep 0.1. Okay. Just do a make just in case I know I didn't make any changes. Run that. Grab this. Run it on this new PID. Then over here, I'm going to do a partial read. Look at that. It's going to sleep and waking up each time. So let's do something a little bit better here. So that was 1 meg. This is a gig size. So I want to do just 10 seconds. So I'm gonna add 2 zeros here. So that should be able to read in like 10 seconds. And I'll just kill this. I don't really care about that anymore. Or 10 ticks, roughly. Why is it not reading, saying that it's reading? Shouldn't it be say, hey, echo, I'm reading, I read that many chunks? Yeah. Okay. Oh, okay, because there's like a lot of chunks. And DD just takes a while to read it. Maybe our file is too big, to be honest. Let's lower our file size. DD. So this is like what? A gig? Let's do like 10,000. Yeah. Or we'll do 10 megs. There we go. Base 64. Here we go. Try this again. This guy here. Okay. Partial read. Okay. We'll just stick to a meg here. All right. Okay. I'm just going to comment out the sleep just to see how fast we can do a read. Pew. So that took fewer reads than the DD command. You know what I'm going to do? I'm going to say echo temp big file .b64, pipe that into that, send your output to there. Delta between test, or not even delta, I'll use a SHA-1 sum of test and temp big file .b64. The same. And if I time this whole thing, this round trip time of this whole thing, can I do that? This has to be bin bash -c. Oh, and I need netcat to close shop when it's done. We'll kill this. Oops, I meant to kill that. Q. Q0. Oh yeah, and then they do the it's not right. I don't think this is gonna work, but we'll try it. Q0. Oh, it did work. So RM test. So we don't have anything there. We'll do our time. And if we now SHA-1 sum the two, they're the same. And it took less than I guess 9 milliseconds to do that transfer. And it did multiple send files. So it was a large enough file to be written multiple times. So we know the partial reads and writes are now working as expected. Okay. I'm going to make a commit and then hop off here. So git status. Lots of stuff going on here. Let's do a get at all just to get the state all in the staging index. To do, I'm going to say get restore staged to do.md. I'm also going to say that for test temp big file star get status. All right. Test I don't really need. Vim up to do and make IO more robust in situations that have non-blocking or partial. So we did that. Implement HTTP1 gets. That's going to be a big task there. I think everything else is legit. So let's do get DC. The partial write I need to update to remove that. Bin partial write to not have these things at the end. Okay. Git add that. Git. So I'm gonna start a buffer over here. And we're just gonna say, okay, we added some scripts to test the server and inspect the server. Get status, get DC. We refactored a bunch of stuff. We wrapped all headers in pound if and def and included them in the C files. I would just say included them. Is that all headers? That's extracting the record stuff. ASM generic error. What the hell is that? In worker.c? That might be the problem. So I got the wrong error now. Source worker. Sorry, not worker.h. Get out of here. Worker.c. Why can't I just include error node.h? Okay. Close connection. Make writes and reads okay. Sounds like a good commit message to me. Get CI, and then I'll just grab the buffer here, yank that, put it up here. So implement partial writes and reads. I'm going to say reads and writes. I'm just going to say that. Okay. Cool. I need to add a remote for this. I don't even have a remote. My sinuses are freaking out right now. Let's go ahead and create a repo for this. We want to call this epoll file server. Epoll file server. Public, off, no, create. I don't want to do any file creation. Okay. I don't want to be called main either. It's master. Freaking idiots. Get remote, add origin. Git push origin master. I hate that stuff. Master. This guy here. Okay, let's push, refresh. Oh, yeah. Vim to do. Add usage. Fuzz test. Maybe we can do some stuff like add Docker file. People like Docker files, so. I'll put a question mark on that. Add for building and running. Okay. There we go. I think we're at a good stopping point here. There we go. Okay. Cool. This is a multi-threaded non-blocking epoll-based file server that serves files over HTTP 1.1. Worker threads are used to allow for parallelism and to keep cores. Oh, I need to we need to add diagram. Yeah. Worker threads are used to allow for parallelism and to keep cores as saturated as possible with an IO bounded workload. This project mainly exists for me to learn about epoll and also serve as a baseline in performance comparisons with IOUing. So I'm happy with this implementation so far, but I guess maybe it's my inexperience with, hold on, let me fix this freaking cable. Got caught under the desk. Maybe it's my inexperience with C, but I feel like it's really easy for me to get off in the weeds of like, oh, I forgot to handle this edge case. I forgot to handle this edge case. I forgot to handle this edge case. Whereas in Go, I feel like the edge cases are fewer. Maybe it's just my experience with Go is that I kind of understand where the edge cases come from. And I'm able to kind of pare things down. Whereas with C, it's like, okay, an error occurred. How do I unwind this state appropriately? Get the connection into a state that's appropriate, or close the connection, or terminate the process. There's like a lot to like think about when a error event occurs. And errors occur all the time in C. So it's like you need to kind of think through all those different permutations and make sure you handle them correctly and test them. And that's the other thing, testing. With Go, it's very easy because it comes with a testing framework to write tests to like unit test your stuff. And unit testing, you really explore the edge cases a lot quicker than doing manual testing from like an actual socket. So I think I'm going to add to the to-do. Let's go over here. Find a unit test framework for C and write some damn unit tests. We'll leave off the damn just in case I accidentally commit it. But yeah, I mean, having some type of like testing framework for unit testing framework for C, where I can pull up a function, throw all the different possible inputs at it, see how it behaves and handles all the different scenarios, would be a lot easier than the way of testing it now. I feel like this program is sufficient complexity to where unit testing would really speed up my iteration cycles, because I wouldn't be going back to like squash these silly bugs, you know? Go just has really robust tooling around testing and coverage. Same thing with Python. I'm sure Zig has something similar, but I'm not familiar with that in C. I'm sure there's something there, but I'm not familiar with it. So yeah, it is almost 7 and I'm starving again. So I'm gonna hop off here. But yeah, we got a lot done today. Let's check out our commit graph. So it hasn't been very solid this week. Some of the code I wrote yesterday, obviously, and I didn't commit it yesterday, so it didn't land. So yeah. What did I do today? 5 commits in 1 repository. Yeah. That's weird that it's like that. It's like a freaking scroll. Yeah. Well, it certainly is the most code I've written. Most of this is just like reading stuff like this, and just the Linux programming interface commits. What was my first commit over here? That's just joining. What was this thing? Oh, this is when I did that patch against Amarchi. And this is when I created that repo for Linux programming interface. I really want to get better at like consistently committing. So I didn't do any commits this week. I mean, I've been stressed out this week. I had a lot of stuff going on, some personal stuff, and I got sick. So I mean, it justified. Like Tuesday, Wednesday, Thursday, I was just destroyed. And then Friday, I did do some work on the epoll server, the initial work. I just didn't commit it on Friday. So these 3 days, I can understand. But yeah, okay. I think this is in a good state. I did, over my lunch break, I went through all the books that I have kind of pending, and I rank ordered them. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13 books, technical books. It's about 2 feet high, stack of books that I have for things that I want to read this year. And top of the stack right now is the C programming language, KNRC, because I've only read about half of that in a previous life, and I just want to read the whole thing, check the box, put it on the completed stack. And then after that is the computer systems, a programmer's perspective, which will be kind of like an ultra learning project where we learn a lot about the internals of computer systems. And then I want to get into some CUDA programming. So I have CUDA by example, and then programming massively parallel processors, then BPF performance tools, learning binary analysis for Linux ELF binaries, systems performance by Brendan Gregg, the SRE book. I've read a good chunk of that by now, so it'll be a review for me. After that, I have the Programming Rust book from O'Reilly, a Data Science from Scratch book, and then CLRS, which is an algorithms book, Strang's Linear Algebra, Introduction to Linear Algebra, and then the Structure and Interpretation of Computer Programs. So that's the current stack. It's rank ordered from like stuff that I really feel like I want to get read down to like the least interesting to me right now. Like Structure and Interpretation of Computer Programs is a Lisp book, and I'm not super excited to deal with Lisp, so that's why it's at the bottom. So yeah, I figure like as I find books that I want to read, I'm just gonna like buy them and insert them somewhere in the stack and just work on it. This year I'm just gonna be about getting more and more learning done. And I might start taking interviews this year, so I'll probably have a few interview prep books that I do, which are going to be focused on algorithms and stuff as well. So yeah, lots of stuff ahead of us. I'm going to go ahead and hop off now, though. Cool. All right, I'll be on tomorrow. See ya.